Okay, combustion is taking place inside the cylinder of this engine. Now what is happening over here is that once the combustion has taken place, heat is being produced. That heat is converted to, or this heat energy is converted to mechanical energy. Okay, so in this way what is happening is that heat is capable of doing some work. Why? Because if I take two sources, an engine always operate between two sources having a temperature difference. So this is my T1 and this is T2. तो संग्राम एमती ना कटी कटी जाऊँ चालूनी ठीक से चालूनी ठीक से कटी कटी जाऊँ देख एमती गोटे वार्ड तुम लिखो देखो रही Please do hold on for a minute. We are having some kind of technical glitch. We'll be back in a short while from now. Masuk? Ini masuk. Well, students, we are back now, and let us continue with the topic that is we were dealing with heat. Okay, so I'll just start it once again. So we have discussed, we have seen that heat is actually a form of energy because it is capable of doing work. Okay, that means if I'm taking a heat engine, I'm taking an heat engine. Alright, so combustion is taking place inside the cylinder. So what I'm obtaining is heat. Alright, so this heat I'm converting to work. That means now heat is capable of doing some work. So that is why we say heat is a form of energy. Alright, so how does this engine operates is that we have two bodies here. One is having a temperature T1, other is T2, and T1 has to be mandatorily not equal to T2, and I will place a heat engine in between this because a heat engine will only operate when it is placed between two bodies having a difference in their temperature. Fine. So the T1 is having a higher temperature. If they are not equal to, that means say one temperature will be higher, other will be lower. In this case T1 I am saying to be greater than T2. Okay, so if T1 is greater than T2, the heat that is extracted from T1 is Q1 and the heat that is rejected is Q2. So my work, whatever work it will be done, will be the difference of Q1 minus Q2. Okay, so that means what is happening, this heat is actually Q1 heat is getting converted to work. How it is getting converted to work is actually some part of this Q1 is getting converted to work and the other part and some part is rejected to the sink. Okay, we cannot convert 100% of heat to work. No, this is impossible. Okay, this is actually impossible. We may name this as Kelvin Planck's statement or PMM1, perpetual motion machine 1. Not required, that is a part of engineering thermodynamics, so you don't have to get into it. Okay, so you need not have to refer or need not have to study that, but I hope this basic part is clear to you so that I can proceed ahead. Fine. Okay, all right, so now let us move to the next part of it. Now normally how do we measure heat? Heat is actually calculated in various forms. Okay, but heat is actually, I will say, it is a function of temperature. Okay, that means if I am increasing the temperature of some body, this will definitely imply that heat will also increase. Okay, heat will also increase. Fine. Okay, now we will understand how do we measure this term called temperature and what is temperature. So it is, there are also better definition than the definition which I am going to write, but from your examination point of view this definition is adopted because questions whenever it is asked from temperature and that too from the definition of temperature, it is always asked from the definition which I am going to write down right now. Alright, so keeping in view the definition which I am going to write right now, questions are normally asked in your general examinations. Okay, so you don't have to study the specific or a very detailed definition of temperature. Alright, so you just have to know the basic definition. Fine. So temperature, how do we define the temperature? It is the degree of hotness or coldness of a body. Alright, now what do I mean by degree of hotness or coldness of a body? Let us understand this. Now I have two cups here. Okay, there are two cups. One is cup A, other is cup B. Now I have here, so this is having cold water. or this is having hot water. Now this hot and cold are actually two relative terms. There is nothing called which is absolutely cold or which is absolutely hot. Now how do I say that this is a cold water cup, this is a hot water cup? How can I judge? Alright, how will I able to judge? You can simply try out, say, touch the liquid slightly with your finger and touch the other part of the liquid here slightly with the finger. Okay, you will find that the water present over here is much warmer as compared to the water present over here. Alright, so that is why we say this is cold water, this is hot water. Now since I have said you that this is hot and this is cold water, we have already concluded. That means we can say that temperature in case of hot water is higher as compared to temperature in cold water. Okay, so TH is greater than TC. Alright, so degree of hotness or coldness of a body will always define you the temperature. That is nothing but what we say is that the temperature of a body is higher as compared to the temperature of another body. It is because of the relative hotness or coldness of that body. Okay, I hope that basic definition of temperature is clear to you all. Now how do we measure temperature? Let us see. Temperature is basically measured by two devices. One we have thermometer, other we can say there is pyrometer. Alright, or in fact another device there is known as thermocouple. Alright, now there are so many devices to measure the temperature, but mostly we deal with thermometer. Thermometer are also of various types. There is clinical thermometer, that is normally used by doctors to measure the temperature of your body. There is laboratory thermometer. Okay, and there is also called resistance thermometer. Alright, but these two normally are preferred in industrial use and in laboratory use, but in our day-to-day life we refer to the clinical thermometer. Yes, I hope it is clear to you all. Now normally temperature is measured in 5 different units. Okay, in 5 different units. From your examination point of view, we will be seeing what are these 5 different units. But this thermocouple is normally fitted in your air conditioner. Say if you have set the temperature of air conditioner to be 25 degrees Celsius, the moment the temperature of the room, because air conditioner will keep on cooling the room, the moment it goes below 25, say 24.9 degrees Celsius, so what this thermocouple is going to do, it is going to cut off supply to the compressor. Okay, so it is normally used in your air conditioners. Pyrometer is used to measure very high temperatures like the temperature of sun. Okay, the temperature of sun, that is 3000 degrees Celsius. Okay, so it is measured in 1000 degrees Celsius. Wherever you have a possibility of temperature, pyrometer is used to measure those temperatures. Okay, so now let us understand very important part of this.